So in the last lecture, I discussed about the reactivity of these three compounds, and this is more reactive than this is more reactive than this, that we had already discussed. Now in this lecture you will see some more examples. First example is like we have a diene like this. This is a more reactive than a normal diene because we have two methyl groups here which gives electrons. Because whenever there is electron-negative group present on this diene, the reactivity is obviously that increases. So when you are going to add it with the group like this, C double bond O H. So this is your aldehyde group which is electron withdrawing. So this is your diene, this is your dienophile. Diene with the two electron donating groups, and dienophile is one this aldehyde electron withdrawing group. So what happened? Just mark it 1, 2, 3, 4. And here is your AB. So new bond is formed between this and this. It doesn't matter in this case because this group is asymmetrical. Otherwise you have to see the way by which this molecule reacts with the diene. How it reacts with the diene, because these two carbon A and B, they have a different electron density. Because when it withdraws electrons like this, so we have a new structure formed like this, O negative H double bond, and here we have a like this, and here we get a positive charge. It means your carbon B that is more electron deficient as compared to A. But in this case it doesn't matter because this molecule is symmetrical. So by one way or two other we can add it to like that. So what product is formed here when you heat it? So just to make a cyclohexane ring, simple. Because in this Diels Alder reaction, this ring is formed. This is a unique characteristics of this reaction. So you mark it 1, 2, 3, 4. 1, 2, 3, 4. A and B. Now write the other groups which are present here. 2 and 3 methyl group. So write here methyl group. And number A, we have aldehyde group. So now this, if there is aldehyde group like this, now this carbon marked A, that become a chiral. So what? We have two isomers. So either this CHO group is above the plane like this, or it may be below the plane like this. Okay, so this is your 1, 2, 3, 4. This is your A, this is your B. So any these two products are possible. Okay, next example. So suppose we move with a simple line, this, and adding a like this. So product is formed. When you heat it, predict the product. So just write 1, 2, 3, 4. Write here A, here B. Bond is formed between 1 and A, 4 and B. And here we have a triple bond. So this bond that moves here. One bond from here that moves here. One bond from here that moves here. Now in this case we get a cyclohexadiene. One double bond here, one double bond here. So mark the numbers 1, 2, 3, 4. This is your A, this is your B. So what is present at A and B? So just mark COOEP, COOEP. So this is your product. Okay, next is, again take this simple diene. Now in this case we have a double bond, COOME, COOME. These two are the electron withdrawing group which are attached to dienophile. So which products are formed? When you heat it, so the 1, 2, 3, 4, here is your AB, bond is formed between 1 and A, formed 4 and B. So these two electrons they move here, these two electrons they move here, and these two electrons they move here, form a cyclohexane ring. Mark date 1, 2, 3, 4, and mark it AB also. Now at A and B we get a chiral center. So either these two groups they will be, we can draw it like this or we can draw it like this also. Both are the same thing. Okay. So by two ways it can add to this. So there is a set addition, both the AB added from the same side. When this is added or this is added, we get a two isomers. Okay. So one will be like this. So here we say that both groups are cis in the same side. So the products formed are with the cis configuration. Both the products formed with the cis configuration. Either both groups are above the plane or both the groups are below the plane. So 1, 2, 3, 4, this is A and this is B. So these two products are possible. Okay, move to next problems. Next we have again a locked diene, but this is quite isolated, not involved in any resonance. And when we added this dienophile, very reactive because we have a two cyano group which are electron withdrawing. So we heated. What product is formed here? Again, this molecule may be like this also. Okay, like this. Both sides, on both sides may be added to this double bond. So this is 1, 2, 3, 4. This is your AB. So bond is formed between 1A and 4B. As usual, we have a cyclohexane having a 1, 2, 3, 4 A and B. Okay, which groups are attached to A and B? Both cyano, like this. Which groups are attached to any other group? Where are these two carbons? You can say these are 5 and 6. Where are these carbons? They are attached between 1 and 4. So attach here. Between 1 and 4 you can add it like this. This is your 5, this is your 6. So this molecule can be represented by a better way, like this. We have CN. This is one way to represent it. This is another way to represent it. Say we have CN. Because this group going to react by two ways. Okay. So now in this there is 1, 2, 3, 4. This is your 5, 6, and this is your AB. Same here. 1, 2, 3, 4, 5, 6. This is your AB. This product is your endo product, and this is your exo product. Here the CN groups, both the CN groups, they are opposite to 5 and 6. They are opposite to 5 and 6. Generally, endo is more stable because these groups are present on axial position. Though both this is cyclohexane thing, and when both the groups these are attached at A and B, they are on the you can say axial position. That is more stable. Generally, endo product is more stable. But in this molecule, this 5, 6 and these cyano groups, they are on the same side. Ectorial position. These are ectorial position. That's called exo product. So generally, endo product is more stable. Okay. Next is suppose we take a diene again, an open diene like this, and we are going to add this time a trans product. So here we have COOME, COOME. It's trans. Now when you heat it, which product is formed? Mark it 1, 2, 3, 4. This is your A and B. So bond is formed between 1 and A. because this dienophile is symmetrical. Both sides same group is same electron withdrawing group is attached. So what is the product? Draw the cyclohexane like this. Mark it. Mark 1, 2, 3, 4. A, B. Now which groups are attached at A and B? C, O, O, M, E. But both the groups, they are opposite position. You can say this is trans alkene. So here we must add a trans. One group is above the plane, another group is below the plane. Trans give trans, cis gives cis. So that's why this Diels Alder reaction is stereospecific. Okay, when you take cis here, suppose this is again I am taking the same example, COME, COO. You already done this example. So now in this case we have a cis. Okay, so 1, 2, 3, 4, A and B. So bond is formed between 1A and 4B. So when you heat cyclohexane, okay, 1, 2, 3, 4, AB. Now which groups are attached to AB? 2, COOME and CO. Both are on the same side. So you will draw it like this. Either both are above the plane or both are below the plane. So this compound is your meso compound. This compound is your meso compound. That will form a racemic mixture. So trans give trans, cis gives cis. You can say this is basically a syn addition is there. Okay. So when any alkene undergoes syn addition, that give meso. Okay. This is your cis alkene. Okay. And addition is your syn. So there is a rule when we have a syn addition plus cis alkene, product formed is meso. Okay, and in this case we have a trans alkene. Okay, and addition is syn plus trans alkene. Trans alkene, that will always give a racemic mixture. So note these points. So this is about the stereochemistry of alkene. When something is added to alkene by syn, cis alkene give meso, trans alkene give racemic. Okay, now how to decide the stereochemistry of group? Now any compound, suppose we have a diene like this. Now see it carefully. Here is also some group. Here the group is attached which is called outside. I will write it O. Both groups are outside. And the group present here, I, is called inside. Here is also inside. This is about the diene. What about dienophile? Dienophile may have groups like this. The groups which are present on this side, we take them as exo. On this side, we take them as endo. Because this diene has two faces, it may add to this dienophile by two ways, either from this side or from this side. So we get a different product. So there is the same stereochemistry of your endo and your outside. Endo outside have the same stereochemistry in the product, and exo inside have the same stereochemistry in the product. Exo inside. So we can take an example. Okay, based upon this. So just take an example. First example is, so this is your substituted diene. For now, is this more reactive or is this more reactive? Which is more reactive out of these two? This one. There is a repulsion. There is no repulsion. Moreover, there is 2 methyl groups. Okay. So in this way we can compare the reactivity also various compounds to a Diels Alder reaction. So suppose we take this compound and adding a compound like CF3. What is CF3? Is electron donating or withdrawing? It's actually electron withdrawing because 3 fluorine highly electron active atoms are attached. Okay. So diene with 2 methyl groups which are inside here, inside, and dienophile with 2 electron withdrawing group which are endo. What is the relation between inside endo? Inside endo are opposite. But these two groups are the same side. This is inside, this is inside. So in the product, these two groups, they will get the same position. And these two are on the same side. Cis, they will also get same position, but the position of this methyl group will be different from this CF3, opposite. Because this group is inside, this is endo inside, they are opposite. So then you heat, what do you get here? Draw the cyclohexane. I will writing numbers. This is very important thing to writing number to get the real and actual product without any mistake. So 1, 2, 3, 4 AB. Now here is this is 1, 2, 3, 4. Here is your AB. Now 1 and 4 have 2 methyl group, but they are on the same position. You can write them above the plane or below the plane. That's up to you. But they must be on the same face. Both are on the like this. So both methyl groups, they are on the above the plane because both are inside. They are cis actually. Now this group methyl is opposite to this group. So if this group is above the plane, this CF3 group will be below the plane, and this CF3 will also be below the plane. So at A we will write CF3, at B we will write CF3. So this is your product. And this product is your meso. No other isomer is formed. So again, you can see this is your cis alkene. There is a syn addition, and we get a meso compound. More example. So now we have, say like this. Okay. Or adding this phase of this molecule. These two are same but have a different phase adding to the molecule. Now this is your inside, this is your exo, inside exo. See here, inside exo, both are on the same phase. That is the difference. So what is the product form? Draw cyclohexane. Mark as 1, 2, 3, 4, A and B. So bond is formed between this, bond is formed between this. Now, we have this methyl group. These two methyl groups are inside, but they are cis, they will be on the same phase. To make it above the plane or below the plane, that's up to you. So 1, 2, 3, 4. Here is a methyl group, say like this. Here is a methyl group, say like this. These two groups are also will be on the same phase because inside exo are on the same side. So your product form is, so this is not a meso. Okay, this is also meso. Yeah, this is also meso compound because again we have a cis alkene and adding this. You can draw by another way, making all these above the plane. That will be the same molecule. These 4 groups are below the plane. You can make it above the plane also. That will be the same product. Okay, next example. Suppose the product is like, reactant is like this, and adding again this. Now, this is your outside, this is your inside, and this is your endo. This is also endo. This is 1, 2, 3 and 4. This is A and B. And you heat it, draw cyclohexane ring. Marked as 1, 2, 3, 4 AB. Now, see carefully, we have two attached groups. Outside endo, same side. Outside endo will be on the same side. Either both will be above the plane or both will be below the plane. Okay. But this inside group and this endo, they will be opposite. Inside endo will be opposite. So make this group above the plane. Okay. So when you make this group above the plane, this group will also be above the plane because they are on the same face, outside endo, same side. Now if this is above the plane, this will also be above the plane because both are cis. So this group is also above the plane. Now this inside group, that will be below the plane. So this is your product. Okay, one more example. So now we have a sufficient example to get the practice, like 1, 2, 3, 4 plus I am adding same CF3. Now you can easily form the product. Both are outside, endo, outside endo are on the same position. So all the 4 groups will be on same position. Just draw the cyclohexane ring like this. 1, 2, 3, 4, AB. So here suppose it is above the plane. This will be also above the plane, CF3. This will be also above the plane, CF3. This will be also above the plane, methyl group. So this is your product. So in this way we decide. One more example to make it very clear. Now I will take here this example. This is your diene. Plus now I am taking trans. Mark it 1, 2, 3, 4. This is your outside, this is your inside. And this is your endo and this is your exo, AB. New bond are formed between 1A and 4B. So when you heat, just draw cyclohexane ring. After that you will see where to attach the groups and how to attach the groups. Now, outside endo, inside exo. It means the position of this group and this group will be same. Position of this group and this group will be same according to the stereochemistry. So you can suppose I made this above the plane. This group is above the plane. This is outside. Now which group will be above the plane? This group, endo. So here this at B, this group will also be above the plane. Now obviously if this is above the plane, this is outside, this is inside, this will be below the plane. So at number 4 we will make a below the plane like this. And this group has this group, both have the same symmetry. So at A we will like this. So this is your required product formed.